we are moving this to the end point.
Okay.
This you hold. I am playing it again. This given some result.
Okay.
So from here to midpoint it will calculate once. And from here to end point it will calculate. In between it is calculating the velocity, it is giving 679. So the concrete is good.
Very good.
Very good.
Very good.
So it is giving you good value even under this test. So this you can note down and say under surface testing. I will say this.
0.84. How to remove one 0.80 or add?
See, whenever you are doing this,
Okay.
so you have to keep a book. So mention point number 1,
This
ID
side,
number
this
1,
side,
this column, column 1, column in between or top. See, generally,
customer they will give it.
generally 10 feet one column will be there.
Okay.
So from bottom 1.5 feet don't test,
Okay.
because all aggregates will go and sit there. Jelly alla yeah, it'll settle. So you leave that. And even rebars. And the steel overlapping, everything is done within that 1.5 feet.
Yes.
So in between you leave the 2 feet, 1.5 feet or so, test it.
Okay.
Then midpoint.
Okay.
Midpoint, why it is important? Because all aggregates will go and settle down. So in between there, whether it is good or not. One box is around 6 feet or so generally. So in 6 feet, bottom 1.5 feet, everything will go and settle. Then only whatever remaining jelly will come up. So in between, when you are pouring one more round, so sometimes there is delamination.
Okay.
Because if there is no proper bonding.
Only mortar is in this top surface of this.
Yes. So in between, when you check, that mortar will be there. There also you will know whether strength is good or not. Then at the top, again when you are not till the roof, leave 1.5 feet and then do it. Because again rebar overlapping will be there, or concrete this thing will jelly will be too high. So aggregates are too high means obviously it is good. There is no problem. So we have to identify the problem, not try to verify which is already good.
We are giving result in the rebound amount the very less value is there. We are not taking the average value. What is the lowest value? I will get the report. Why or what?
One in rebound hammer, please. For rebound hammer, mark 100 mm by 100 mm. One grid. Wherever you want to select it. You are marking around 10 impacts. Minimum 10 impacts you have to take. Or this thing is saying around 8 or 9. But to make it easier, take 10 impacts. So you will get some reading 45, 42, 43, 40, 40. 35 it will give. Then again 50, 50 to 55, like this it will give. When you are going on 55, that means you have taken reading on a aggregate, or there is a rebar inside. So rebound value is very high. So this is you are taken reading on a slurry. Only finds this thing without any eliminate this also. So add a few more tests. It should be within the average variation should not be more than 5 R. Suppose it is 40, it should not go beyond 45. Or it should not go less than 35. And the 10 readings you add up. All 10 readings you add up. You divide it by 10. Mean value of it. That is the average. And that average you look into the graph and arrive at the compressive strength. You have to see. Don't take the lowest one and decide. Or don't take the highest one and decide. Here it is, the last floor. If you go up, there is one doors are direct. So this is how it is done.
Okay.
So that you have to be careful.
Okay.
So this is surface testing.
Okay.
What we have to do. There is one more testing below.
Hmm.
That we have to identify cracks
Oh.
in concrete.
Okay.
Generally in concrete, either a block or not.
Okay.
Suppose there is a crack here.
Yes.
So this crack, how much it has gone inside, that we have to find out. So perpendicular crack depth. Suppose I marked here. Suppose there is a crack here, visible crack. So we can see directly what happens. It has to go directly. Suppose it goes fully, this member is waste.
Okay.
It is a fault. Generally what happens when it comes, there is a crack, it either goes like this or like this, like this, like this.
Okay.
Generally it percolates to the right or to the left.
Okay.
So crack doesn't go fully, air cracks are not happening. So this perpendicular crack depth, from here how much it has gone inside, that you can read. You can get the reading here by doing that test. So now this is done. Okay, I am going back to the main menu. I am going back again. The first one is surface testing. What we have done. Bottom one is அந்த picture வருது அங்க பாருங்க ஒரு crack கூட வருது. You can see there is one crack indication also there. So we have to find out the depth of that crack. So generally what we do, there is no crack in this, I am just showing it to you. Okay. Suppose there is a crack.
Okay.
Keep it on either side.
Okay.
Depending again on the thickness of concrete. Okay. So keep it on either side. Take one reading.
Okay.
Okay. Again move equal.
Okay.
Move equal. Not more than the depth.
Depth of the concrete.
Maximum 150 mm only you can go. And do one more test.
Okay.
So either reading varada. What happens? There is one transducer here, one transducer here. First we have kept. Suppose this is around 300 mm block. Maximum I can go up to 300 mm.
Okay.
But initially center point you mark.
Okay.
So you 300, 150, 150 varadiya. Inge 150 varadu, inge 150 varadu. So mark it at 75, 75.
Okay.
So take one reading. So keep the transducer here at 75 and do one testing.
Okay.
So when you do the testing, it will go from here. It will go and it will give you one reading. T1 will come. Okay. Then when you move it to the end up to 300 and you are doing a testing, it will go inside and it will come. It will give T2. After that it will give you velocity and depth of crack in centimeters. CMS. It will display here only.
Okay. You will test it?
Yeah, there is no crack here. We will get one, what do you say? So I am keeping it here.